All right, so on some of these, some of you know, again, remember this from Algebra 2, some of you don't. So if you can look at that and know what the answer is, terrific. Don't look at it and guess. Say, oh, I think it's negative, or I think it's a fraction. If you don't know, show work. So these you're just evaluating. You're not solving, you're evaluating. But you can make it into kind of a solving question. So we can say 1 over 25 to the what is equal to 5. We need like bases. So this 25 can be 5 squared. So 1 over 5 squared to the what equals 5 to the first. Even though you have a like base, it's still not, they both have to either both be in the numerator or both be in the denominator. So we need to bring this up and say 5 to the negative 2 times what equals 5 to the first. And then now that you have your like bases, you can say negative 2 times what equals 1. Divide by negative 2, and you get your answer of negative 1/2. I don't have to see that work. I'm really not going to grade work on a problem like that. The evaluate ones, it's just going to be, what's the answer? You've got to write it down. There's not going to be any partial credit on an evaluate. Either it's right or it's wrong. Here, 16 to the what equals 8. Whenever the what you're looking for is in the exponent, that's when you have to use like bases. Some of you can look at that and know what it is. Terrific. If not, like bases are for when the missing number is in the exponent, which it is here. So that's 2 to the 4th times what equals 2 to the 3rd. Now that we have like bases, we can say 4 times what equals 3. Divide by 4, and you get your answer. Okay, that's the work to get to the answer. If you can't just look at that and get to the answer, that is what you do. If you're confused what to do, that's what you do. You write it down. Same thing here. 7 to the what equals the square root of 7. We can't figure, square root is not an answer, it's not a value. So 7 to the what equals 7 to the power over root. So your answer is 1/2. Letter D is similar to letter A, but not exactly the same. We can't just say, oh, it's the same, so it's going to be negative 1/3. That is not how you do these problems, okay? If you can look at it and figure out, that's one thing, but don't try to compare it to another problem and then just make it exactly the same, because it's a little different. Here we had the base we had to change in the base. Here, the number we have to change is in the argument, okay? So it's going to be a little different. Another thing I don't think we've talked about yet is arguments and bases. So arguments we've talked about since Unit 8, they have to be positive. But what we do in pre-cal, also the bases have to be positive. So a base and an argument both have to be positive. And when we get to a problem in a second, I'll show you when that matters. It'll matter today and then the next couple days as well. So we say 1/3 to the what equals 27. So we bring this up. So 3 to the negative 1 times what equals 3 to the 3rd. So we can say negative 1 times what equals 3. Divide by negative 1. And we get our answer of negative 3. So a little bit different than letter A. Letter A was a fraction and negative. Letter D was not a fraction. It was just a nice whole number. And then E, F, and G are just using the log and the natural log, one of the properties that we learned. So E and F are with the log. So B raised to the log base B of x equals x. So here we get 15. Here we get 5. G is just the natural log version of that. E, which is the base, to the natural log of x equals x, because the only base that natural log can have is e. So this would be 2. So using those properties, you don't have to use the properties. You can always use the definition of a logarithm, going from log to exponent, exponent to log. Those will always work as well when you're working these problems. All right, so now for today, really, we're not doing much different today other than now there's an equal sign. So the x could be in different places. It could be the x, it could be the argument, or it could be what it equals. Okay, that x can just move around, but you just have to remember when you're solving for x, if x is the base or x is the argument, then those numbers must be positive. So if you get an answer that's not positive, it's either no solution, or if you have two answers, maybe one of them doesn't work. If you have two negative answers, then maybe neither one of them work. So we still can do your little loop-de like you like to do right there. 4 to the 1.5 equals x. Now, 1.5, we can't do that. We don't have a calculator. So on your homework, don't say, oh, well, it's a decimal. It probably means use the calculator. No, you have to be able to do these without the calculator. It'll tell you on your homework when to use a calculator. So we have to change that to a fraction. 4 to the 3 over 2 equals x. So now we can work that by changing that to a radical. 4 cubed and the square root, bless you, equals x. So we can cube 4 and take the square root, or take the square root of 4 and then cube it. Both ways we get the same, and it's pretty easy either way. The square root of 4 is 2, cubed is 8. The cube root of 4 is 64, square root is 8. So either way, x is equal to 8. And it's the argument, okay? X is the argument, and that's positive. If we got a negative answer right there, then it would be no solution. All right, the next one, 10 to the 3 equals x. We can evaluate, fine, we can solve that. We can put 3 zeros after a 1 and actually get that answer. On the test and quiz, it'll be very obvious, like whether you should actually multiply it out or not. 2 to the 5th, 2 to the 6th, you can multiply that out. If it ends up being 2 to the 50th, would I ever make you multiply 2 50 times without a calculator? No, I would hope you would understand and have enough common sense to know that is not something that I would make you do. Okay, so it'll be very obvious whether you should or should not keep going. Here's one where the argument is not just a single x or it's a number. It's a polynomial, but we still do this the same way. 2 to the 3rd is going to equal the argument. So 2 to the 3rd equals x squared minus 1. Now from here you can do this a couple different ways. You can bring the 2 cubed, which is 8 over and factor, or you can bring the 1 over and solve using square roots. If you solve using square roots, you just have to remember when you take the square root of something, it's plus or minus. Cube root, not plus or minus. It's either plus or it's minus. Square root, fourth root, it's plus and minus. So 8 equals x squared minus 1. Bring that 1 over. Or bring the 8 over and set it equal to 0. Either way, you're going to get the same answers. When you take the square root, so we put the square root on there. It wasn't there. That's when it's plus or minus. So we get x equals plus or minus 3. Now, we don't automatically get rid of the negative 3. I never said answers can't be negative. Okay, I said bases and arguments can't be negative. So you have to check. This isn't one of those problems check to make sure that you did it right or not. You actually have to check to see if both those answers work. All you do is plug this back in. This is the argument, x squared minus 1. So when I plug in 3, I get 9 minus 1. That argument's positive. When I plug in negative 3, I get 9 minus 1. That argument is also positive. Therefore, both of those answers worked. If you have two answers and one of them works, one of them doesn't, you exclude one of them. If you have one or two answers and none of them work, then it's no solution. Letter D is the same thing. It's just this is the argument right here. So it's 5 to the 0 equals log base 3 of x. So we're just going to have to do this twice. Neither time is difficult. So we all remember, hopefully, that anything to the 0 power is 1. And now we just do that again. 3 to the 1 equals x. 3 to the 1 equals x. We don't write to the first power. So x equals 3. Some of these, again, as I've said, every single day, you're going to see things that keep happening over and over again. Because there's only so many numbers we can give you without a calculator. If you have a calculator, there's lots of things you can do. But without a calculator, same things. It's going to be nice numbers like that. If it wasn't, it could have been x squared equals 10. The square root of 10 is just the square root of 10. We can't find that, so we would just leave it as it is. And then these last problems are just using the calculator. So the first three, you still have to know the definition of a log. Those last two, these are, you could just plug in. So these don't require as much practice as some of the stuff you have to practice using the parentheses and all of that. These you could probably do without a lot of practice. I could just give you the natural log of 1 plus root 3, and you could plug that in without any practice and get the right answer. Doesn't matter what mode you're in, all you have to do is set it up. So here, okay, we can't type in log of x. We can type in 10 to the 3.7 equals x, though. That is something we can plug in. So in our calculator, we would 10 raised to the 3.7 and get our answer, 5011.872. Rounding to the thousandth. This is when you would round to the thousandth. Here, this would be 10 to the negative 0.3 equals x. So 10 raised to the negative 0.3. Be sure you use the negative sign and not the minus sign, or it'll give you an error, and I won't be able to help you with that error. 0.501. Natural log of x equals 4.2. Now, this is a problem we could put on the calculator or the non-calculator part, okay? If I gave you this problem right here on the non-calculator part, you would say e to the 4.2 equals x. The directions are solve for x. If you did not have a calculator, you have just solved for x. If you have a calculator, you just type it in. If you don't know where the e button is, down this left-hand side, right above the ln, is an e, so you just go second natural log. The e pops up, and then you just type it in. 4.2, 66.686. So those you have to know the definition. Those last two you don't. You just type them in. Log 2. So log 2, enter. There's your answer, 0.301. The second one, natural log. Oops. Natural log of 1 plus the square root of 3. Now, because there's nothing on the outside of the parentheses, it doesn't matter if you close them or not. Okay, you can close it once, twice, or not at all, and you'll still get the same answer. So 1.005. Remember, the thousandth only matters by the fourth number. So this fourth number is the only one we look at. We don't like start at the very end and just keep rounding up forever. You look at the fourth number. That determines whether the third number goes up or stays the same. So there are how you